Yo, what's going on guys? I'm Code Red, and welcome to the second part on how to make a Rocket League bot with RedUtilities. In this part, I'm going to be introducing you to the process of bot creation and explaining how it all works. So let's get started. First, I'm going to go over and try to explain how bots even work in the first place, as I think it will be very useful to have a good baseline knowledge on how all of this stuff works. So first, let's talk about how Rocket League bot actually communicates with Rocket League. You see, Rocket League actually directly supported Rocket League bot about a couple of years ago by providing them with an API that Rocket League bot can use to communicate with Rocket League. If you don't know what that is, that's pretty much fine. I'm just going to briefly try to explain it. So, in summary, Rocket League has a way of communicating with the Rocket League bot program. And when I say a way of communicating, I really mean a mode that Rocket League can be opened in. And this mode is only turned on if Rocket League bot opens the Rocket League program for you. This is why you cannot open Rocket League yourself when starting a match using Rocket League bot. You have to let it open it for you, or else Rocket League won't start up properly. When in this Rocket League bot mode, you can't access any online playlists, which is just to prevent people from trying to play with these bots online. And of course, it will actually communicate with the Rocket League bot program. And this mode basically gives the Rocket League bot program the ability to access the game state, which is stored in a structure known as the game tick packet. The game tick packet allows the Rocket League bot program to access the current state of the game, including the position of the ball, the position of all the cars on the field, how much boost are on the boost pads, whether or not they're activated or not. All of that stuff is all stored within the game tick packet. All the stuff that is actively changing in your Rocket League game. It also provides Rocket League bot with the field info. The field info contains things that will not change over the course of the game, like the location of the goals and location of the boost pads. All of these structures are very key, as without them, your bot would have no idea what's going on. Now, of course, getting this information is key to the bots working properly, but none of this will work if the bots can't actually control their own cars on the Rocket League field. So the Rocket League API that Rocket League built also provides Rocket League bot the ability to send commands to Rocket League to move all the cars on the field. You can also do a lot more with this ability, including moving the ball and teleporting the cars around and such like that. This is known as state setting, and some bots actually do use state setting, but not any of our competitive bots. It is against the rules to submit a state setting bot to like a normal tournament or something for obvious reasons. You can't just have your bot teleport the ball into the goal every time. So anyway, now you basically get the idea of how Rocket League bot communicates with Rocket League. To summarize the summarization that I've already done, 120 times a second, right? Rocket League sends the Rocket League bot program the game tick packet, and then Rocket League bot gives the game tick packet to all of your bots. In this case, it gives it to your bot through the game tick packet argument in the GetOutput function, which all bots have access to. So then when your bot receives the game tick packet, it will, look at it, figure out what to do, and then using the GetOutput function once again, it will return the controller values the bot wants to perform for that tick. And then Rocket League bot will send those commands over to Rocket League, so Rocket League knows what inputs the bots want to perform. And that's basically all there is to it. If you don't fully understand it, that's fine. As long as you get a basic understanding of how it all works, I think I've done my job properly. As ultimately, the most important part of that entire process that I just explained is your bot's part. The part where your bot takes the game tick packet, figures out what all of it means, and returns controller inputs. And all of that stuff all happens within the GetOutput function that all bots implement. So let's go check out the GetOutput function for RedUtilities. To do that, let's open up Visual Studio 2022 and open our bot solution, which should be named bot.sln right here, unless you renamed it for whatever reason. Then when it's done opening, you should see a hierarchy on the left that looks something like this, and I'll quickly explain what all of this means. This is the bot solution, and inside of the bot solution, we have two projects. The bot project, which contains all of our bot specific code, including our strategy, which you can see right here. And inside of the RedUtilities project, we have all of the RedUtilities specific code, which includes the GetOutput function, which we need to check out. And you might be wondering, hey, why isn't the GetOutput function in the bot.cs file in the bot project? You know, since it's specific to our bot, I feel like that's pretty important to have the GetOutput function in there. Well, if you actually looked carefully in here, you can see that the RedBot class in here, which is our bot's class, actually derives from RUBot, which actually is the name of the class in bot.cs. So our bot's class actually derives itself and takes all of the behavior from this class, which is why it's so important to understand everything in this file. And you can actually see as well, this RUBot class actually derives itself from another class, which is the bot class that comes with the RLBot.net namespace, which allows us to access things like ball prediction, field info, and it allows us to overwrite the GetOutput function, which we are now going to check out. So at the beginning of the GetOutput function, we reset our controller variable. Now, our controller variable basically just keeps track of all of our inputs that we return at the end of the GetOutput function and allows us to access the controller inputs from anywhere. And we want to reset it at the beginning of each tick so that we have a fresh set of inputs to manipulate every tick. Then, after resetting the controller inputs, we check if we are not ready, meaning the bot has just started up at the beginning of a match. And if that's the case, then we are going to get the packet ready by calling getReady and then passing in the packet, the game tick packet that Rocket League bot gives us as a parameter. And if we scroll up to the getReady function, you can see some stuff that basically gets the bot ready at the very beginning. It initializes our extended renderer that East made for me, thanks East. And it also initializes some static classes, which contains all of the information in the packet, just organized a little bit better, including the field and car static classes, which we can check out now. The car static classes contains information on all of the cars, so all of the cars on the field, all of the blue cars on the field, all of the living blue cars, all of the living orange cars, meaning all the cars that are not demoed. And then the field class contains all of the field info, such as the goals, the boost pads, and some other stuff, including the surfaces that our cars can drive on and land on in the arena. There are some other static classes I'm going to quickly go over as well, including the game static class, which contains the score line and some other variables relating to the game, such as the current time, whether or not the game is unlimited time, if it's overtime, if a round is active, if it's on a kickoff pause. There's a lot of game-specific stuff in here that you can check out as well. And there's finally the ball class, which is actually not a static class because we can create an instance of it, but it has some static variables, including the location variable, which contains the current location of the ball in the game, and the velocity variable contains the current velocity of the ball in the game. So this is just some basic stuff that you're going to need to understand in order to use RedUtilities. It's basically the way you just access basic information. You don't access it through the packet, you access it through these organized static classes. So this getReady function just gets all of that ready, and then we process the packet here as the next step, which basically updates all of those static classes with the latest information. It also will account for things such as if people leave the game. So if the count from the last tick does not equal the current count, then we will reinitialize the car static class and take that new person into account. And then we update all the rest of the static classes and do some other stuff related to kickoff, including setting this isKickoff variable equal to true if we are on a kickoff pause and the round is active, meaning the kickoff has just started. And also, we reset this action if the kickoff has just started. Now, you might be wondering, what the hell's an action? What are you talking about? Well, actions I will explain in a little bit more detail later in this video, but basically, you just need to understand that a bot in RedUtilities will be executing an action at any given time, and it's basically just behavior that runs every tick that we can enable and disable just by setting this action right here. And again, we'll go into more depth later, but for now, we're just going to skip over the details and continue with the GetOutput function and see that the next step is to run our strategy code in the run function. And you can see the run function contains, well, nothing, because it's abstract, meaning it has to be overwritten in the class that derives itself from this class, which of course is our RedBot class inside of the bot.cs file, which you can see the only thing of relevance in this class actually is the overwritten run function, which contains RedBot's default strategy, which we'll go over at the end of this tutorial. And then lastly, in the GetOutput function, after running our strategy code, we do some more action-related stuff, which we'll explain later. It basically just runs our action and does some other stuff. Then we update delta time, which is a variable that keeps track of how long it's been since the last tick. You don't really have to understand that. And then we return the controller inputs at the end of GetOutput. Of course, the most important step, make sure our bot actually works properly. So yeah, that's the GetOutput function in all of its glory. It might be a little hard to understand right now, but hopefully it wasn't too complicated. Basically just gets the packet ready, gets it encapsulated in all of these static classes, runs our strategy code, and runs any action if there is one. And now let's actually check out the run function and start messing around with controller inputs and such. You can see this is the strategy, which we'll go over later, but right now it's a little too complicated looking, and we're just going to quickly comment it out, which you can do by pressing Control-A, Control-C, and then saving the file right there. Again, we'll go into what this actually does later, but for now, we're just going to ignore it and start adding our own code. So how do we want to do this? What do we want to do? Well, really, we can do anything. Let's try just driving directly at the ball, for instance, not accounting for where the ball might be in the future or anything like that, or boost or collecting boost or anything. Let's just set controller.throttle, which is our throttle input, equal to 1, which will basically just be holding down the accelerator at all times, which of course isn't very interesting if we're not steering towards anything. So let's do that now. And this is a basic way we can do that right here. Now you might be wondering, basic? Well, what the hell is this? I don't understand what any of that means. Well, don't worry, I'll quickly go over it now. We're basically setting the steer input, which is just driving left or right, left being -1 and right being +1, to this expression right here, which let's break this apart. The first part that you might be able to understand is me.right. Me is just our bot's car, and right is simply our car's right-hand side. It's a vector pointing to the right relative to where our car is facing. And then we're going to take the dot product with that vector and another vector, which is me.location, so the current location of our car, and then pointing from me.location to ball.location, which is the current location of the ball. So this is another vector. This whole expression that I'm selecting here is another vector pointing from me to the ball. And we are taking the dot product with me.right and the direction from me to the ball. And the dot product returns 1 if these two vectors are pointing in the same direction, and -1 if they're pointing in the exact opposite direction, which is of course exactly what we want, because if the direction from me to the ball is exactly pointing in the same direction as my right-hand side, then of course we want to turn to the right. And if it's the exact opposite, then yes, we want to turn to the left. Now, we are multiplying this by 5 because most of the time this function will not return 1 or -1. Most of the time it will return like 0.3 or -0.7 or something between that, which means most of the time your bot's going to be steering a little bit shallowly. It's going to be not very sensitive and quite slow. So multiplying this by 5 should make it a little bit faster. But of course, by multiplying by 5, that gives the possibility of this expression returning 5 or -5, which steer will not accept. So we have to cap this expression between -1 and 1 by using utils.cap. There's a lot of useful stuff in utils, such as cap and lerp and inverlp and quadratic and lots of other stuff that you might want to check out. But for now, you're probably only going to be using cap. But anyway, this is what that does. Basically steers directly towards the ball and sets throttle equal to 1. So we're not going to be doing boosting or anything like that. And yeah, let's test out our new strategy. So hit Control-S to save, or File, Save All, and then click Build Solution to build our solution and get it turned into an executable that can be run by RLBot GUI. Speaking of RLBot GUI, let's open it up now. And let's test our bot against ourselves. Why not? Now, this will be much worse, just to be clear, much worse than the default RedUtilities bot, because the default RedUtilities bot takes advantage of actions and lots of other stuff that I programmed myself, which should be a lot more intelligent than what we just created right here. This is just to show you the basics of bot creation and understanding how to use GetOutput and how to make your bot do things, you know, set inputs based on variables such as our bot's location, the ball's location, and all of that. So let's just put our bot in a team against our human, which is just us, and let's wait for Rocket League to open right here. And now if we wait just a second, we can see that we open up in a game against RedBot, and unlike the test we did last time, we can see that RedBot is a little less intelligent. He is in fact driving towards the ball. Will he drive up on the wall? A little bit. He's driving directly at the ball though. Will he flip over? He will. He's driving, turning around. And he hit the ball again. Very nice. You can see our strategy seems to be working. He's in fact driving towards the ball the best he can. Not very great. Not boosting, not doing anything. But you can see this is the start of how bots get created. This is what's known as an ATBA, or always towards ball agent, and it's generally the first thing you do when doing bot creation. And this is really just the bare bones level of what creating a Rocket League bot is. It's setting inputs based on information in the game, so the ball's location and the car's location. And of course, this is not what our bot will be in any sort of final stage. So let's work towards that. Let's start understanding those actions that I explained earlier. So to understand actions and their potential and how they work, let's go check out the action.cs file. Seems like a pretty good place to start inside of the actions folder in RedUtilities. And you can see, whoa, this is only 14 lines long. That's pretty short. And that's because really this only contains the iAction interface. Hopefully you know what an interface is. Hopefully you're familiar with C# at all, or else you would not be following at this point, I don't think. And this is basically like a template for all the actions, meaning all actions will contain a run function. Just like our bot, a run function runs every tick and will, you know, provide the GetOutput function inputs based on what action is being performed. And then we have two other variables right here, including the finished variable, which is basically a flag that our action can raise and say, hey, I'm done. Set me to null. I'm no longer running. Set a new action. And interruptible is basically another variable that is used in a few places and is encouraged to be used in your own custom strategy code that basically says, hey, I'm an action that could be interrupted by any other action at any time. So if this action is not interruptible, then that means this is an action like a dodge that, generally speaking, we do not want to be interrupted. If we're currently dodging, we don't want to, say, suddenly have an inclination to drive back to our goal, because that will probably cancel the flip and do a whole lot of other gross stuff that we don't want. So all actions derive themselves from this, and actually a lot of other actions derive themselves from another action class, which is the shot class, which is an abstract class. It's not an interface because it has its own behavior, which derives itself from the iAction interface. As well as finished, interruptible, and run, we also have some other variables in here, including a lot of stuff that I will just quickly go over, but these are basically all universally useful for shots. So this includes the ball slice, which is a little of a weird name, but it's basically a class that, well, you can see right there, a predicted state of the ball in the future. So I mentioned ball prediction earlier in this video that predicts where the ball will be in the future, up to 6 seconds in the future, in fact. And a ball slice is just one of those moments in the future. So, of course, a shot will have a point in the future where we're aiming to hit the ball at, and that is this moment. The slice right here is that moment that we want to hit the ball at. We also have a shot target, so where the ball will end up after our collision, hopefully, and some other stuff like a target location. This sounds very similar, but it's basically, well, you can see the final position of the car at the point of collision, so where our car should be once we collide with the ball, and a shot direction. You can see it's the direction from the car to the ball at the point of collision, so what angle we plan to hit the ball at, basically, which is pretty similar to some other variables in here, but these are all useful in all of the shots that I create. There's some other stuff in here, but basically you just need to understand that this is a shot abstract class that all shots derive themselves from, and will be useful in just a second. So that is a quick summary of what actions are, but, well, how are they used? You know, how do you actually use an action? Well, if we go back into the bot.cs file and Control-Z this and uncomment this code, you can see we are setting our action variable, which is a variable inside of the RUBot class, which we can see right here. You can see the action variable right here, which is set to null by default. And we are basically setting that action variable to various actions, such as this drive action, which drives ourselves to our goal. And this works because in the bot.cs file in the RedUtilities project, the RUBot class has a section in here that I kind of glossed over, which will run the action if it is not equal to null. And now I will finally explain the rest of this and what it actually does now. So after running the action, we will check if anyone has hit the ball. And if they have hit the ball and the action is interruptible, or the action is finished, then we will reset our action. So what do I mean by that? Basically, if the action is finished, then we want to set action to null because, well, it's finished. We need to find a new action now. But we also want to finish an action if it is interruptible and someone has hit the ball. This is because if we're, for instance, going for a shot, right? And we predict we're going to hit the shot in like 1 second, but then suddenly someone hits the ball, right? We're going to have to find a new shot. And shots are generally interruptible, so this will automatically set our current action equal to null as soon as someone new hits the ball, which is vitally important if, for instance, we're going for a shot and someone hits the ball and now we need to look for a new shot. Or, for instance, you're going for boost, but suddenly someone hits the ball and now suddenly we need to be defending. You know, we need to reset the action in those circumstances and reassess our current situation. And so, yeah, that's basically what actions do and how you work with them. So let's finally explain what the strategy here does. It will be the final part of this tutorial, and we will, of course, be working more with strategies in the next tutorial, but I want to explain what this simple strategy does so that you understand how to work with actions and how that code is written. So let's go through this. At the beginning, we basically just render some text. You don't really need to understand this. This does not have anything to do with our bot's behavior. It just provides some text that shows up on the screen in the top left that shows what action our bot is currently running. Pretty useful. Probably want to keep it there. And then we check if our bot is on kickoff and no action is currently being run. So as I mentioned earlier, as soon as kickoff starts, action is equal to null. And so this will basically say, oh, right at that moment, is it kickoff and is actual action equal to null? Okay, let's go for kickoff, right? And so this was basically with that condition, we're going for kickoff. Now, of course, when it's kickoff time, we don't actually necessarily want to go for kickoff, which is some behavior that we actually have in this strategy. You can see we have a going for kickoff variable set to true by default, but then we go through a list of all of our teammates. And if any of our teammates are closer to the ball than us, then going to kickoff will be turned from on to off. But assuming that's not the case, then we will go for kickoff, which has a quirk of meaning that if two red bots are equidistant from the ball on kickoff, they will actually both go for the ball on kickoff, which is probably something you want to change in your own strategy. Maybe you'll implement left goes, which is a very common strategy, or something else. I don't know what else, but I mean, it's you do you, whatever. Anyway, and then finally, after deciding whether or not we want to go for kickoff, we will set an action accordingly. So if we are going for kickoff, then we'll set action to a new kickoff action. And if we are not going for kickoff, then we're going to set action to a new get boost action. So we'll just go get boost on kickoff. And then, of course, if it's not kickoff, right, let's say we've just finished kickoff, then let's go for a shot. This is basically just a ball chase strategy, so we're only going to be going for shots here. So if we're not going for kickoff, then we're going to check if an action is null. Because, of course, we don't want to be always setting a new action every tick. Because remember, run runs every tick. We don't always want to be setting a new action every tick. That's why this function has the extra condition of action being equal to null. Because if it was just if is kickoff, then that means every frame during kickoff we will be setting a new action, which we do not want. We want to just set an action initially and then let that action take its course. So yeah, this will be checking if we are not doing kickoff, right, else, and action is equal to null, or action is drive and action is interruptible. Now this second condition is a little niche. It really just has to do with this specific strategy. But basically, we have this second condition because the only time our action is a drive action is when we're driving back to our goal, which we'll only drive back to our goal in the case that we can't find a shot, which I'll explain in a second. So if we are driving back to our goal, we want to constantly go inside of this condition to look for a new shot, because since this is a ball chase strategy, we want to always be looking for a new shot. If for whatever reason we can't find a shot, then we'll go back to our goal, but we still want to be checking for new shots. So that's why the second condition is here. It's basically to say, oh, we're driving back to our goal. Well, we still want to be looking for shots, so we still want to check inside this condition. So if action is equal to null, or we're driving back to our goal and we want to be checking for shots, then we're going to check for a shot using the find shot function, which we'll explain in more detail next episode, as we'll be using it a lot. But basically, it takes in a target and a shot check predicate, which basically will decide on a shot to go for. Again, explain it more in the next episode. But for now, let's just pretend this is a magic function that finds us a shot to go for, right? And whatever shot we find will be saved in the shot variable. Now, it is possible that this shot variable is equal to null, meaning we couldn't find a shot in the next 6 seconds, because that's how far ball prediction goes. It goes for the next 6 seconds. So it is possible we cannot find a shot in the next 6 seconds. And if a shot is not found, then we want to account for that. So action is equal to shot, but this double question marks will account for if it is equal to null. If it's not equal to null, then we'll set action equal to shot. But if it is equal to null, then we'll refer to the expression after the double question marks, which will set our action equal to action if it's not equal to null. Now, of course, if this first condition is here, then of course it will be equal to null, and therefore we'll go to the last condition, which is, oh, we're going to set it to a drive action and drive back to our goal. But if it's not equal to null, meaning this second condition was true, so like right after kickoff, let's say, right? We go to the second condition, we can't find a shot right here, and so we just set our action equal to a new drive action, so we're driving back to our goal. Then the second time this comes around, even though action is not equal to null, we're still going to go in here because it is in fact a drive action and the action is interruptible, let's say, so we're not like dodging or something. Under those circumstances, then we're going to find a new shot. If a shot's found, then we'll interrupt the drive action, but if it's not found, we don't want to set it to a new drive action. We want to set it to the same action that's currently being gone for, because we don't want to reset an action while it's currently running to the same action, because that will cause some wonky behavior. Like, for instance, if we set a drive action every frame, we will never dodge, and of course we want to dodge. So we need to check for that right here by checking if action is equal to null, or if it's not equal to null, I mean. Then we want to set action equal to action. So yeah, hopefully that wasn't too hard to understand, but I will quickly summarize it for people who didn't really understand right now. Basically, if it's kickoff time, then we'll check if we're closer to the ball than all of our teammates. If we are, then we're gonna go for kickoff. If not, we're gonna go for boost. And then we will be constantly looking for a shot. And if we can't find one, we'll drive back to our goal, but we'll still be constantly looking for a shot while we're driving back to our goal. And otherwise, we'll be going for a shot as soon as possible. And yeah, that's basically what this strategy does. It's surprising how well it works, but it is fairly simplistic than what I'm gonna guess your strategy will look like at the end of the day. And your strategy is actually going to be developed pretty soon, as we are going to make our own strategy in the next episode, which I hope you're excited for. And we'll also be checking out some more stuff to do with this find shot function, and maybe trying to flesh out some other things. You can leave comments in the comments below if anything I explained in this episode was a little too hard to understand. I know I went pretty fast, and even going as fast as I did, this video's probably pretty long, which I regret. I'm sorry about that, but I really tried my best. There's a lot here, and I'm just trying to get through it as thoroughly as possible. So any specific questions, I'll try to answer in the comments, or I will go into detail and explain in the next episode. And yeah, hit the like button down below if you're excited for that new episode, and hit subscribe if you want to get notifications on when that comes out, or if you want to see other videos by me. I make other tutorials and other coding content, which will be coming soon. And yeah, see you in the next video. Bye!